Okay, this is section 7.5, and it is, section 7.5, quotients. Quotients meaning this is going to be about radical expressions that are in fraction form, one divided by another. So that's what the quotients is all about. Okay, so first we're going to talk about and look at what we have done prior to this. So as you can already see the answers, but negative 25, oh dear, we need to have this a lighter color. We had white before, let's fix out white here. Okay. Which equals, the negative comes out as I. So this is root 25 and an I. Root 25 being 5, we get 5i. This is x to the 8 minus 3. Okay, so that is x to the 5. This one is interesting. This is going to be x to the 5x plus 1 minus x to the 2x minus 3. Or sorry, no. I did this wrong. Hang on. There we are. All right, no, this isn't right. Okay. Sorry, this was just 2x. It was this bit right up here. We were just pulling out the two exponents. All right, so 5x minus 2x is 3x. And then 1 minus a negative 3 is 1 plus 3, which gives me 4. So my final answer would be x to the 3x plus 4. This is kind of the stuff we're going to be doing this particular lesson. All right, quotient property of radicals. Notice what it's saying is I can take the nth root of the numerator and put it over the nth root of the denominator. Okay, so this gives you a way to simplify things. Okay, so for example, if I had the square root of 4 over 9, what's the square root of 4/9? I don't know. So I can split that, and now I'm going to have 2/3. Okay, so that splitting up is an important skill. All right, so how to simplify a radical. A radical expression is simplified. So this is a definition, okay? So when your problem says, simplify your answer, or simplify this expression, or something like that, it's expecting it to be simplified. This is what that means. How far do you have to take it? Okay, so it is simplified when there are no perfect nth powers in the radicand. Okay, what does that mean? That means it cannot have something like the 4th root of 16, because 16's 4th root is 2. It's a perfect nth power. It's a perfect power of 4. So you can't have those. You have to simplify those. That has to be, you'd have to write 2 for that. Okay, no fractions in the radicand. Whoops, I just crossed that out. I didn't mean to do that. There we go. No fractions in the radicand. That means I can't have square root of 4/3. I have to get this rationalized, okay? So that's not going to work. You can't leave it in that form because you have a radical 3 in the denominator. That's supposed to be an equal sign. Apologies. Right? So now I have 2 over root 3, so I would have to rationalize that. We're going to talk about what that means. No radicals in the denominator. That's exactly what I was just talking about. You have to rationalize them. When simplifying a cube root, rationalize the denominator by multiplying both the numerator and the denominator by a factor that makes the radicand in the denominator a perfect cube. This is true for any nth root. Well, I'll explain these. You'll see examples. Expressions involving imaginary numbers can be simplified in the same way other radical expressions are simplified after they're expressed in terms of I. So no negatives inside of an even square root. Actually, no negatives inside a radicand. That negative is going to come out and be a negative on the outside. If it's even, it's I. If it's odd, it's just a negative. Okay. Now, example, the cube root of 2 over 12. Well, this can simplify to 1/6. So we do that. Now we're going to take the cube root of the numerator and the denominator, right? We split this into two pieces. Well, the cube root of 1 is 1. Any root of 1 is 1. The fourth root of 1 is 1. The 100th root of 1 is 1. So 1 is super easy to simplify. So we simplify. We don't see anything we can do with that one. So now we're going to have to rationalize. Okay, so, oh, you know what? In these slides, these things don't go away. Interesting. All right. So what I have here, I'm going to give myself a slightly darker color because I'm going to write on this. Okay, so 1 over cube root of 6. I'm going to Okay, that was interesting. That's a weird little symbol. Is 6. Remember, I squared is a minus 1. That's over here at the end. So 6 minus 1. All right, 6 minus 1 is 5. Plus 2i plus 3i is 5i. 6 plus 1, 9 plus 1 is 10. Okay, so now I have to simplify this. I can factor the 5 out.